Hello students, good evening. Today we have exercise 2.2 in the chapter of real numbers. Okay, and the first question is express the following numbers as a product of its prime factors. Then you also know prime factorization. So first question is our first question is 468. Factorize 468 first by 2. Then we find 234. Again divide by 2. Then we find 117. Again divide by 3. Then we find 39. Again divide by 3. Then we find 13. And the last factor of 468 is 13. So we find 1. Okay, and we can write the factors of 468 in the form of 2 multiply 2 multiply 3 multiply 3 multiply 13, and we can also write in the form of 2 square multiply 3 square multiply 13. Okay, third part is 140. 140. Factorize 140. First time divide by 2, then we find 70. Again divide by 2, then we find 35. Okay, divide by 5, then we find 7, and the last factor of 140 is 7. So we find 1. We can write 140 in the form of 2 multiply 2 multiply 5 multiply 7, and we can also write in the form of 2 square multiply 5 multiply 7. Okay, and the last part of first question is fifth, 20,570. Factorize the number. First divide by 2, then we find 10,285. Okay, divide by 5, then we find 2057. Okay, divide by 11, then we find 187. Again divide by 11, then we find 70, and the last factor of the number is 17. So we find 1, and we can write in the form of the factors 20,570 equal 2 multiply 5 multiply 11 multiply 11 multiply 17, and we can also write in the form of 2 multiply 5 multiply 11 square multiply 17. Okay, note the answers. Our second question is find the HCF and LCM of the following pairs of integers and verify that HCF multiply LCM equal to product of the integers. Okay, then we have some important facts as follows. Write in MTR, and first fact is HCF multiply LCM equal to product of numbers. Product of numbers, and we take two numbers A and B. Okay, so A multiply B. product of A and B. When we have value of integers and value of LCM, then we find the value of HCF by the relation of HCF equal product of numbers upon LCM of numbers. And if we have value of HCF and integers, then the relation is LCM equal product of numbers upon HCF. Okay, and same procedure apply on the numbers one by one. Then we find value of A equal HCF multiply LCM divide by B. When we do not have the value of B, then we find the value of B by the relation B equal HCF multiply LCM divide by A. Note the MTR and continue the question. Second, first part is 96 and 404. First part is 96 and 404. Factorize 96, then we find divide by 2 times, so 48. Again divide by 2 times, so 24. Again divide by 2, so 12. Again divide by 2, so 6. Again divide by 2, so 3. And last factor of 96 is 3. Then we find 1. And we can write in the form of the factors of 96. 96 equal 2 multiply 2 multiply 2 multiply 2 multiply 2 multiply 3. And we can also write in the form of 2 power 5 multiply 3. Okay. And second number is 404. So factorize 404 by 2, then we find 202. Again divide by 2, then we find 101. And the last factor of 404 is 101. So we find 1. Okay. And we can write in the form of 404 equal 2 multiply 2 multiply 101. And we can also write in the form of 2 square multiply 101. Okay. And the value of HCF. Value of HCF and value of LCM. It means highest common factor, it means lowest common factor. Okay. So define the minimum power of common factor in both numbers equal 2 power 4, 2 power 2 minimum power of common factors of the value of HCF. So we find 4. Okay. And highest power of common factor and other numbers, then we write the value of LCM equal 2 power 5 multiply 3 multiply 101. Okay. And verify the value of LCM and HCF, then we know that HCF multiply LCM equal A multiply B. The value of A equal 96 and value of B equal 404. Okay, so 4 multiply, write in the form of powers. So 2 square multiply value of LCM 2 power 5 multiply 3 multiply 101 equal 96 multiply 404. Okay, you can also write in the form of powers. So we have 4 multiply 32 multiply 3 multiply 101 equal 96 multiply 404. Multiply the numbers, then we find multiply 32 by 12, then we find 384 and divide by 101, then we find 384 0 0 0 483. So 4873, and the multiply of 404 and 96, 6 4s are 24, 9 4s are 36, 9 4s are 36, 4 8 7 8 3. So we can write 38784 equal to 38784. So LHS equal RHS. So LHS equal RHS, and the value of HCF and LCM are correct. Okay, note the question. Next part is, we take third part, 90 and 144. 90 and 144. Okay, so factorize 90 and 144. When we factorize 90 by 2, then we find 45. Okay, divide by 3, then we find 15. Again divide by 3, then we find 5, and last factor of 90 is 5, so we find 1. And we can write in the form of 90 equal 2 multiply 3 multiply 3 multiply 5, and we can also write in the form of 2 multiply 3 square multiply 5. Okay, and factorization of 144, when we divide 144 by 2, then we find 72. Okay, again divide by 2, then we find 36, again divide by 2, then we find 18, again divide by 2, then we find 9, divide by 3, then we find 3, and the last factor of 144 is 3. So we find the factors 144 equal 2 multiply 2 multiply 2 multiply 2 multiply 3 multiply 3, and we can also write in the form of 2 is 2 power 4 multiply 3 square. And the value of HCF is minimum power of factor, okay, and the common power of factor. So we write in the form of minimum power of 2 equal 1 multiply minimum power of 3 equal 3 square. So value of HCF equal 18, okay, and the value of LCM is maximum power of common factor is 2 power 4 multiply 3 square, and the other part is 5, okay. This is the value of LCM and it's the value of HCF, okay. Again we know that HCF multiply LCM equal A multiply B, then we find (18) multiply 2 power 4 equals 16 multiply 45, square of 3 equal 9 and multiply 5, so we find 45 equal 90 multiply 144. So multiply 18 by 16 and multiply by 45, so we find and multiply 144 by 90, then we find multiply by 9. So 12,960 equal 12,960. So we can say LHS equal RHS. Then values of LCM and HCF are correct. Okay, note the question. Our next question is third. In question third, same process according to question number 2. A little difference in question number 2 and 3. Question number 3 is find the HCF and LCM of the following integers by applying the prime factorization method. ओके, प्राइम फैक्टराइजेशन मेथड से ही करना है इसको भी. Then see question number third, and the first part of question number third is 12, 15 and 21. 12, 15 and 21. Factorize 12 by 2, then we find 6, again divide by 2, then we find 3, and the last factor of 12 is 1. So we can write in the form of 12 equal 2 multiply 2 multiply 3, and we can also write in the powers 2 square multiply 3. Factorize 15. Factorize 15, then we find 15 divided by 3, so 5, and the last factor of 15 is 5. Then we find 1, and we can write in the form of the factors of 15, 3 multiply 5. Okay, last number is 21. Factorize 21. Divide by 3, then 7, and divide by 7, so we find 1. 7 is last factor of 21, so we can write in the form of 21 equal 3 multiply 7. So value of HCF, minimum power of the common factor, and the common factor is 3, and the minimum power is 3 power 1, so we find 3. And value of LCM equal common multiple multiply 2 square multiply 5 multiply 7. Okay, so the value of LCM is 4 3 is 12, 12 5 is 60 multiply 7, so we find 420. Okay, note first point. And all the parts of third question is same in process, so do yourself. Our next question is 4. There is a circular path around a sports field. Raman takes 18 minutes to complete one round. Raman takes 18 minutes. Okay, and second participant is of the circular path while Anupriya takes 12 minutes. Anupriya takes 12 minutes. Then suppose they both started at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? So we find the LCM, then factorize 12 by 2, then we find 6, again divide by 2, then we find 3, and the last factor of 12 is 3, then we find 1. So 12 equal 2 square multiply 3. Okay, factorize 18 by 2, then we find 9, divide by 3, then we find 3, and divide by 3, then we find 1. 3 is the last factor of 18, so 18 equal 2 multiply 3 square. Okay, and the time is value of LCM equal maximum power of multiples, 2 square multiply 3 square. So you find 4 multiply 9 equal 36 minutes. After 36 minutes they meet on the same place. Okay, next question is 5. In a seminar, the number of participants in Hindi, English and mathematics are 60, 84 and 108 respectively. If in each room the same numbers of participants of the same subject are seated, then find the least number of rooms required. Okay, quickly copy the answer. Okay, answer will be, next question is number of participants according to subject. First is Hindi, second is English, and third is maths. Okay, 60, 84 and 108. 60, 84 and 108. Okay, first factorize the numbers. So first is 60, divide by 2, then we find 30, again divide by 2, so 15, divide by 3, so 5, and the last factor of 60 is 5, so we find 1. And 60 equal 2 square multiply 3 multiply 5. Okay, factorize 84 by 2, so we find 42, again divide by 2, so we find 21, divide by 3, then we find 7, and the last factor of 84 is 7, so we find 1. Okay, and 84 equal 2 square multiply 3 multiply 7, and the last subject is maths, 108. So factorize 108 2 times, then we find 54, again 2, so we find 27, divide by 3, so we find 9, again 3, and the last factor of 108 is 3, so we find 1. And the factors of 108 equal 2 multiply 2 multiply 3 multiply 3 multiply 3. Okay, and we can also write in the form of 2 square multiply 3 cube. So value of students seated students seated in a room, maximum number of students, so we find the value of HCF, and the common multiple is 4 and 3. 2 square multiply 3, so we find 4 multiply 3 equal 12. Okay, and the number of rooms equal total students upon 12. So 60 plus 84 plus 108 divided by 12. So we find sum of numbers and the number of rooms is 21. So required number of rooms is 21 rooms. Okay, and the chapter of 2.2 is complete.